we want to try to show that a post machine can do, or PM can do everything that a Turing machine can do, or TM. And I don't have a proof for this in this video, but I do want to show you what we were studying in class yesterday, to show the diagram of how the post machine looks in order to do what the tape head does in the Turing machine. Just one example of that. Now, what the problem we had yesterday was, we want to show that if we have this particular string on a tape in a Turing machine, and we want to shift the tape head left, how do we do that in a post machine? Well, the concept is that in a post machine you wouldn't have anything prior in the store. It would be in a sequence like this. So in a Turing machine you might have A, B, 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 A, and then the tape head is after the A, and you just do a AAL, and it just overwrite that A, and now you move left and you're positioned before the A. That's how you do it in the Turing machine. On the post machine, though, you would already be positioned here, and the string in question would be kind of like a circle. So what we want to do is we want to move this A to the front. How do we do that? Because then we'll be, again, positioned the same way as we are in the Turing machine, starting from a similar type of position. So let's go through this diagram, and I believe it's on page it's on page 469 of the Introduction to Computer Theory textbook by Daniel Cohen. This book right here. It's on page 469. They're going to use 3 letters in their alphabet. I'm just going to show you with 2 letters in the alphabet. But basically, you start. So we're going to go from here, and we're going to get to here. We do a start. Which is the first step in the process. Then we're going to add some kind of a character at the end of this post machine. As you remember, a post machine always has the tape head at the beginning, or not it's not called a tape head, but it's got an add and a read and a write, one at the beginning, one at the end. Anyway, so we're going to add a $, or some kind of a marker character. Let's just, for the sake of argument, use a $, at the end of this string. So effectively what we're going to do is we're going to add a $, here. And then we're going to read the first character. The idea of this whole thing is we're going to read 2 characters at a time, and we're going to remember the one prior. So if we read an A, actually I'll put it this way, mark it like this, make it easier. If I read an A, then I'm going to read again. And if I read an A, then I'm going to add an A. And I want to stress that the A that I'm adding is not this A, but this A. I'm adding this A. If I read a B, then I'm going to add an A. Why? Because, again, it's this A that I'm adding. Here. Okay? By the same token, if I read a B the first time, let's suppose that the first character I read is a B, then I'm going to read again. And if I read an A, I'm going to add a B. Again, it's this B that I'm adding, obviously. And then if I read a B, I'm going to add a B. This B though. So the idea is I'm adding here back to this string after the dollar sign. I'm adding whatever the character was the time before last time. Now, of course, on the next character, I need to find out, for example, the next character here, let's suppose I read an A again. Well, then I want to go back and perform this operation again. After I've added this A, I want to read another, I want to do this read here and follow this A path. We can call this, we can call this read 1. Okay? So this would be read 0. And this here is read 1, 1 being corresponding to A. By the same token, if I read an A here, I also want to go back to read 1. Now, if I, obviously if I do a B, I want to do just the opposite. So if it's a B, I read B. And then I'm going to write whatever, again, the prior one was, or the second to the last one was. So now the question is, what happens when I get to the dollar sign? Well, if I go to the very first, read, and it's a dollar sign, if it's a dollar sign, I am done. It's an empty string, right? If I read the first character and it's a dollar sign, it's the dollar sign I just wrote. So that's done. Now if I read a dollar sign in read 1 here, that means that the last character was an A. And I'm gonna have to put this A at the front of this whole string I just wrote. Okay? So let's just say that if I had a dollar sign here, I would have to, and the book calls it, go to add front. Add front A. By the same token, I'd have to do add front B if it was here. So now, how do we do this add front? On page 468. At the bottom of page 468 it shows how to do this, but I'll just, it's really, really simple. This add front thing is basically, in this case, you add an A, you add a dollar sign. Now remember, you've just read a dollar sign. So now we're going to add another dollar sign at the end, and the old dollar sign's gone. We're going to add an A, and then we're going to read through the entire thing that we just did, the entire string we just wrote, and we're going to keep looping through that until we get to the dollar sign again, and we'll just add. Again, if it's an A, we'll add an A. If it's a B, we'll add a B. And if it's a dollar sign, we're done. We do this whole same thing for if it was a dollar sign on the read B. Except for this would be an add B. Everything would be the same except for we would have an add B here. So the bottom line is that we start from this position as we always do in a post machine. Add the dollar sign. We keep track of the second to the last letter we've read. And if we follow this A path, we add a dollar sign, then we add an A. If we do the B path, we add a dollar sign and add a B, read through the whole string again, and we've effectively gotten this letter moved up to the front here. Hopefully that's helpful. I mean, it is explained pretty good on page 468 and 469 of the textbook. The one thing that they did not show that I think is helpful is to see what the strings look like on the Turing machine and the post machine. Once you kind of understand what's going on, the diagrams aren't so bad. So hopefully that helped.